All right, guys. All right. Now, we finished or we're starting chapter 7 today. So today's going to be the first day of chapter 7. Chapter 7 is going to be going over rational equations. Well, rational ratios, so we're talking about fractions. And the biggest thing with this here is that the variables will be in the bottom of the fraction. Now, something interesting with this here, unlike the functions we've covered so far when we talked about quadratics, higher degree polynomial functions, the domain was all real numbers. It didn't matter what x was. We could plug it into the function and still get a value. Rational equations, there are some restrictions. We call them asymptotes. They're a value that does not work for the function. Because if we looked at this here, 1 over x, which is a rational function, well, x cannot be 0 because 1 divided by 0 doesn't work. We don't have a value for it. So there will be certain values that we have to restrict the functions that will have what we call asymptotes, vertical asymptotes, values of x that won't work for the function. And that's kind of one of the big differences with this here and polynomial functions. Now, before we delve straight into this, we're going to look at direct and inverse variation. Direct variation, it says that we've covered before, you've talked about it before. All it means is that we have two amounts that are going to vary directly. As one increases, the other increases. Or as one decreases, the other decreases. They're going to increase or decrease at the same amount. It's kind of like scaling stuff up, scaling stuff down. It's either increasing or decreasing at the same size. And it comes in the form, so for direct, we can write in the form of y is equal to a times x. This is one way we can write it. We could also rewrite it as x is equal to a times y. Either way, it's the exact same thing. Or if we want to get x and y on the same side, we can divide by x and say y over x is equal to a. And a is just a constant term. It's just a constant amount. It's just a number. We call it a constant. Or we could say x over y is equal to a. It's just a constant value. It really doesn't change anything. If you take a lot of upper level math, calculus, you take those, you'll go into more about what we can do with constants. They're kind of funny in that it's just a number. So 1 over a is actually the same as a, just a number. It's weird how they work, but they're kind of interesting. But these are kind of two ways that we can write a direct variation or have an equation set up as direct variation. So y is equal to a times x, or y over x is equal to a. Now, in some books, they will call it k instead of a, just a constant term. Now, the other one we have is inverse variation. Inverse is all it means is one is going to increase and the other is going to decrease. Whereas one decreases, the other increases. They're going in opposite directions. And the amount that they go in opposite directions will be a fixed amount. It'll be a constant rate. And we can denote it as y is equal to a over x. Or x is equal to a over y. Vice versa. Or if we wanted to put it on the same, we could say y times x is equal to a. Because we're just multiplying both sides by x, getting them on the same side. Questions on this here? So, inverse. So we look at the first one, y is equal to a times x is our equation, yes? Now, what I could do, divide both sides by x. X divided by x, anything divided by itself is 1, so we just have a, is equal to y over. Just another way to write the equation. Because if we wanted to, here, because we have y over x is equal to a, well, we could say x over y, because I could flip it, and this here would be technically 1 over a, because we flipped it. Yeah, but what's weird with this is we can say x over y is equal to a. That's a weird concept that 1 over a and a are the same. But a is just a number. It's a constant term. So that flip is going to end up being applied to A, so we can just merge it together. But that's about it. So that's our inverse and direct variations. Now, before we really start utilizing or kind of messing with numbers and seeing which types are direct or inverse, we're going to look at equations. So we have these three here. As we said, for direct variation, the different ways we have it, we can say y is equal to a times x, or y over x is equal to a. Now, something I didn't point out on the last slide was that if we look at direct variation, when x and y are on opposite sides of the equal sign, they're both in the numerator. They're both on top of the fraction. Technically, we could have it where they're both on bottom, but they're either going to be both on top or both on bottom. Or if they're on the same side, then they're going to be divided. Our other type that we have is inverse. Inverse variation. Y is equal to a over x. When we have it in this form, x and y are on opposite sides. One's in the numerator, the other's in the denominator. Or if they're on the same side, they're both in the numerator. They're both being multiplied together. So we look at the first one here. X times y is equal to 5. Would this be direct, inverse, or neither? It would be inverse, because we have one of our forms is x times y or y times x. So this is inverse variation. We can say inverse. Because it just matches up to one of the forms. And for this one here, our value of a is 5. Just kind of matched up. Let's look at B. Would we say direct or inverse? Because we do have direct, inverse, or neither. It is neither. Now there is one kind of giveaway that it is neither. What are the x and 4 doing? What's our operation? Subtraction. With direct variation in both forms, our variables are being multiplied or divided, yes? With inverse, we're multiplying or dividing. We don't have addition and subtraction with direct or inverse variation. That's kind of a dead giveaway that it's one or the other. Now, is it possible to have addition and it be direct or inverse? Yes, but let's do minus. X minus 4y is equal to 0. Because then we can add 4y to both sides. That's just going to tell us x is equal to 4y. So really, if I have another number there added or subtracted to it, it's not going to work. Lastly, C. It is direct. Now this one here is one of the ones that's a little bit confusing because we do have that fraction. We have that being division of 2, yes? But where is x and y located? They're both in the top of the fractions, the numerators, yes? And the one that has them both on top is direct. Now another way we can look at this is we could say it's 1/2 times y is equal to x. We have our a times y equals x, or x times a is equal to y. If we didn't want to look at it that way, y over 2, if I multiplied this by 2, the 2 that we multiply with and the 2 in the bottom will cancel each other out, leaving us with y is equal to 2x. Y is equal to a times x. So questions on these here? Really, even though it changes 2, 1/2, it's just a number. All right, let's look at these three. How about number 1? If it is direct. Because even though our normal, the way that we write it, y is equal to a times x is equal to y is still the exact same thing. A is 6. How about number 2? Inverse. Because we're just matching it up to our x times y is equal to a. And number 3? Neither, because we have an addition, and it does equal something other than 0. Questions on these here? All right. I think we feel comfortable with those, and we'll move on to the next part of the lesson. So for this part here, we want to determine whether the given set of numbers is direct, inverse, or neither. Now again, when we talk about direct and inverse, the variation, how they vary, is set by a constant amount. There's a constant number that's going to cause the variation to increase either both increase or kind of go in the opposite direction. Because if we talk about direct variation, we said it was y is equal to a times x. We also said that y over x is equal to a, that constant amount. So the way that y and x for each one of these here should vary by the same amount. And for inverse variation, we said that y times x is equal to that value a. So we should get the same number as they do here. If not, if it's not one or the other, then it's going to be neither. So we look at a. We can start off by doing y divided by x. Because y divided by x will show us if it is a direct variation. And I always start off with the leftmost one. So we can say negative 12 over 2. Well, negative 12 divided by 2 is negative 6. Now, negative 6 in and of itself doesn't tell us anything, but it does let us know that we need the rest of these divisions to be negative 6, because if they are, then it's going to be direct variation.
I've done it before.
Negative 6 divided by 4 is negative 3/2. Well, it doesn't reduce fully, but it does reduce a little bit. Are these two the same? So can we say it's direct variation? No. Okay. And really at this point, stop. Because they all have to be the same amount. So it doesn't matter if the next two are negative 6. Since that one's not, it's not direct variation. That means we can move over to inverse. Multiplying x and y. So we can say 2 times negative 12, which is negative 24. Then we move on to the next one, 4 times negative 6, which is indeed negative 24, yes? 6 times negative 4 is negative 24. And lastly, 8 times 3, negative 3, is we get negative 24 across all 4, yes? So that tells us it's what? Inverse. Inverse variation, because that amount, that scale that we had, is the same for all of them. Let's go with, now, this is just extra. You don't really need this here yet. We'll do these on the last, but this is the inverse variation, y equals a over x, yes? A is negative 24. So the equation that actually defines this is y is equal to negative 24 over x. That would be the equation. So if we wanted to find any other number, we can use this here to find it. Does that make sense? Yes? And as we talk about inverse variation, we said inverse as one increases, the other decreases. Or we can think about the origin, 0, 0, x and y axis. So if we look at the x values, 2, 4, 6, 8, these are what? These are all increasing, yes? 2, 4, 6, 8, they're all going up, yes? Now, I'm not counting in the negatives, but negative 12, negative 6, negative 4, negative 3, those are all going closer to the origin. So those are decreasing, the x values are increasing, they're going in opposite direction, so most likely it would be inverse, which indeed it is. All right, well, let's look at the next one. 1, 2, 3, 4, the x values are going up. Y values 2, 4, 8, 16, they're going up. So there's a good chance it could be direct, which it's not. It's y over x. So we can say 2 over 1. 2 divided by 1 is 2. The next one. 4 divided by 2 is 2. Well, it's looking good. 8 divided by 3 is 8 over 3. So the first two worked out nicely. The third one did not. So it's not direct variation. Now just to verify, we can do inverse x times y. So 1 times 2 is 2. Then we have 2 times 4, which is 8. So this, yeah, it would be neither. It would be neither.
Wow.
Incidentally, this equation here is y is equal to 2 to the x, is what it actually is. It would be considered an exponential growth function. So it's going to increase faster and faster as it goes along. Because when x is 5, y is going to be 32. We'll look at 2 more of these and then move on to the last type. So if we look at number 4, we can start off with y over x. So the first y value is 20. The first x value is negative 4. 20 divided by negative 4 is negative 5. Then we move on to the next one. 15 divided by negative 3 is negative 5. 10 divided by negative 2, negative 5. And lastly, 5 divided by negative 1 is, so this here would be a direct variation. And the value of a is negative 5. Do we need to see another example of one of these? All right. Let's move on to the last type. Last thing we're doing. The variables x and y vary inversely. And y is 4 when x is 3. Write an equation that relates x and y, then find y when x is negative 2. So to find the equation, we're really looking at this here, y equals a over x. So it asks to write an equation that relates x and y, so our inverse variation, we're looking at this here. If it asks to find the equation that relates x and y for direct variation, we'd be looking at y is equal to a times x, depending on which one it's looking for. Here, in the homework, we're just mainly going to be looking at this here. Now, really, all we need to know is the value of a, because if we can find the value of a and plug it in, we have the equation. Well, for this problem, they did give us the value of x and y. They said for the given equation, or what we're working with, y is 4 when x is 3. So we can plug it in. We can say 4 is equal to a, whatever that value is, over 3. Because whenever we have that value of a, whatever it is, when we divide it by 3, we will get a value of 4. Now the first thing we can do in solving this is to multiply both sides by 3. Now we did this earlier already today. I'm going to write this out step by step so we see it, just as a reminder of why this works. On the left-hand side, we have 3 times 4, which is 12, is equal to. Here, when we multiply it out, we multiply a whole number by a fraction. The whole number on the outside multiplies just with the numerator, not both. So we end up with 3a over 3. Anything divided by itself is 1. So these simplify out, leaving us with a by itself, which is equal to 12. Now, most of the times when we do the multiplication of 3 on both sides, our a over 3 just becomes a because we've gotten so used to canceling those out. But I feel like it's a good reminder every now and then to remind ourselves why it works. So, plug in 12. There's the first part of the answer. Y is equal to 12 over x. Now we just need to find out what the value of y is when x is negative 2. So we can plug it in. Y is equal to 12 divided by negative 2. So y is negative 6. That's it. So we just needed the equation and the value of y. So when you give the equation, we still do need the y equals, so y equals 12 over x. But that's it. Questions on this here? Are you ready for the next one? So we'll do this one here and one more, and then we'll be done for today. Y varies x, the variables x and y vary inversely. And y is 8 when x is 4. Write an equation that relates x and y. Then find y when x is negative 16. So we're looking at y is equal to a over x. And really, once we find a, we'll have the equation. Now for us here, we can set it up because y is 8 when x is 4. And just like the last one, we can multiply both sides by 4. We don't have to write it out this time. We know that the 4 and 4 will simplify to 1, leaving us a by itself. And 4 times 8 is 32. So our equation is y is equal to 32 over x. And the last thing we need to do is solve it. Y is equal to 32 over negative 16, which is indeed negative 2. Questions on this here? Now, some of the ones on the homework, if when you're solving them, they don't reduce. So if it had been, say, 32 over 7, that doesn't reduce. Leave it as 32 over 7. If you get an ugly decimal, leave it as a fraction. Let's look at this one here, mainly because x is a fraction, it's 1/2. Now the process really doesn't change. We're still looking at y is equal to a over x. Still needing to try to find the value of a. We can still set it up as 16 is equal to a over 1/2, just like we did before. To get a by itself, we can multiply both sides by what? 1/2. Which will get us a by itself, because these here will cancel. 8. So here y is equal to x, or 8 over x. And the x value we're looking for is 2. Yeah, they gave it to us in the instructions. So y is, and that's it. Questions on any of this here? And that's all we're doing today. So your homework is 3 through 8, 11 through 13, 15 through 19.